Yes. Yes. Now, are there any questions on the homework? Any questions over any of the homework assignments? Yes. Now, what we're looking at today is completing the square. Completing the square. Now, we did one problem with this yesterday, looking at completing the square. But we have our main steps. And the first step is A equal to 1? If not, make it so. So the first step with completing the square is A equal to 1. If not, make it so. The second step is to get the constant terms on one side and leave two spaces. The third step is to find C, which is equal to B over 2 squared, and plug in. And we want to plug it in. And we want to plug that value of C in. And the fourth one is to factor and solve. And these here are more or less the four main steps that we have for this here. For solving any of these here. Now, we've already done the first one here, I'm realizing. I'm going to go on and do the second one here. X squared minus 6x plus 9 equals 1. I don't think seeing that one again is going to do too much. Now, looking at this here, and again, the whole square root method, or completing the square method, is to be able to have a perfect square trinomial, set of parentheses square. Now, here, we could actually factor x squared minus 6x plus 9 into a set of parentheses square, because it's a perfect square trinomial. So for this here, we can look at the factors of this. Now, it might be hard to see. Well, one, it's hard to see because the thing's pixelated. But, again, for us to be able to determine if it's a perfect square trinomial, we can check the value of C. Because C for this here is equal to B over 2 squared, yes? And for this problem, what is the value of B? And it would be negative, yes? Negative 6 divided by 2 is negative 3, and negative 3 squared is 9. Yes? Is our C term already 9? Yeah, it's already 9. So what that's telling me is that x squared minus 6x plus 9 is a perfect square trinomial, yes? And as we looked at yesterday, to get our set of parentheses squared, since a is 1, we will have our x. And the number that goes inside the parentheses with x is whatever was inside the parentheses before we squared it. So it would be x minus 3 squared, which really means that our factors were x minus 3 and x minus 3. X minus 3 squared equals 1. Now at this point here, we can square root both sides, telling us x minus 3 is equal to plus or minus. We need to take the square root of 1, which is, what times itself is 1? 1. Really, on a side note, the nth root of 1, no matter what the root is, cubed root, fourth root, fifth root, is always going to be 1. We do need to get x by itself. So we need to add 3 to both sides, yes? So x is equal to 3 plus or minus 1. Can we add or subtract these? Yeah, we can add and subtract them and not have to approximate. So we're saying x is equal to 3 plus 1, which is 4. We're also saying x is equal to 3 minus 1, which is 2. So x is equal to 4 and 2. Now we got 2 nice answers, didn't we? Which means we could have moved the 1 over and solved it by factoring. Got it equal to 0 and factored it out. It also means we could have moved the 1 over and graphed it and gotten the same answers. Questions on this here? Now this one here is the first one we're going to look at as a perfect square trinomial. And one of the things that gives this away is the 8, because again, on all the ones that have worked so far, it's been a perfect square. We've had 64 on the first one, which is 8 and 8. Last one was 9. 9 is 3 times 3, yes? What times itself is 8? I mean, technically there is a number. It's 2 square root of 2. But it's not a whole number. It's not a natural number. It's not an integer. So this here, x squared minus 4x plus 8, we cannot write as a set of parentheses squared. It's still technically, let's see here. No, it's not solvable. It's not going to be a natural or nice number. So we're going to use completing the square to solve this here. So the first step, is a equal to 1? Where is a located? Because our general form is ax squared plus bx plus c. A is the number in front of x squared. For in this case here, is it 1? Yes. Okay, so we're good there. So step 1, is a equal to 1? Yes. Okay, we don't have to do anything because we need it equal to 1. Step B, or not step B, step 2, get the constant terms on one side and leave 2 spaces. Constant terms are our numbers without a variable. So the constant term in this case is 8. So we need to subtract 8 from both sides. We need to get all the constant terms on one side and everything else on the other. So what that'll leave us with is x squared minus 4 minus, minus 4x. Now it does say leave 2 spaces, so plus blank is equal to negative 8 plus blank. Because what we're going to do is find the value of c and plug it back in. So, okay, so we did step 1, we've done step 2. Step 3 is to find the value of c. And c is equal to b over 2 squared. And in our case here, what is the value of b? Almost. No, it is 4. It is negative 4. We need the sign with it. Now again, at this point here, we could try to plug this all in the calculator. That's fine. It would give us the correct value for c, but we need the middle step. Because negative 4 divided by 2 is, which means when we factor this into a set of parentheses squared, we'll have x, and what goes in there with it? The negative 2. Because we always plug in what's in there before we square it. We could plug in the negative 4 over 2, or we can plug in just negative 2. This is why I say don't just plug the whole thing into the calculator, because that middle step where we have negative 2 squared, which is indeed 4, because our value of c is 4, so that means this is 4, and this is 4, because what we add to one side we have to add to the other, which does help us, but knowing that the number before we squared it was negative 2 helps us to be able to factor it to x minus 2 squared. And the other side, the value of c, yes, is 4. Any other questions on this here? Any questions on anything we've done so far? Now we do need to simplify the other side. Negative 8 plus 4 is? Negative 4, yes? Okay. What do we need to do next? Square root both sides, because this is now step 4. Step 4 was to factor. We did. We got x minus 2 squared and solve. Questions? Austin, what are you asking? Because here, negative 8 plus 4. Yep. You're good? No, it's better to ask those questions now than to try to figure it out later. Now, when we square root both sides, here the square root and square would cancel, leaving us with, okay, x minus 2 is equal to plus or minus. So we need to take square root of negative 4. Well, we know the negative is going to come out as I. Anytime we have a negative inside a radical, it's going to come out as I. An even root, which leaves us with the square root of 4. Square root of 4 is? So we have 2i. So x is not by itself, so we need to do what to both sides? Add 2. And according to kind of number theory, or kind of the general way we write this, when we add 2 to both sides, the 2 is going to go in front of the plus or minus. So we have 2 plus or minus 2i. Now is 2 and 2i, are they like terms? Can we combine those at all? That's our answer. If I can't combine them, that's my answer. If we can combine them, or if we can simplify it, there's a like term in all 3 spots. If we have a division, simplify it if you can. But that right there is our answer. Questions on this here? Let's look at the next one. Okay, let's go through the steps. Is a equal to 1? Yeah, the number in front of x squared is 1, so we're good there. Step 2, get the constant term by itself. So we'd add 5 to both sides, which will tell us that x squared plus 8x plus blank is equal to 5 plus blank. Now we know we can put a plus on both of those, because the value of c is always going to be positive. There is one case where we could do a minus, but it's just instead of putting it on both sides, we can put it on the same side. And the only way we can add something to the same side is if we subtract it. As if I put plus 4 minus 4 on the same side, which is just 4 minus 4, which is 0. Essentially, we added nothing. Or we can add it to the same, both sides. Adding and subtracting it to the same side really only comes into play if we are using this with conic sections, which we won't delve into. Now for this here, the next part is to find the value of c and plug it in. And in our case here, the value of b is what? 8, and it's positive. We do 8 divided by 2, which is, and 4 squared is, so we're going to add 16 to both sides. Any questions on this so far? Not going too fast. Okay. So we have our set of parentheses squared. Now we will have x first, mainly because that's the variable. And it's going to be plus 4, because the number inside our parentheses when we were finding c before we squared it was 4, and it's positive, so it's going to be plus 4 inside our parentheses squared. 5 plus 16 is 21. Now we need to square root both sides. Here the square root and square would cancel, leaving us with x plus 4 is equal to plus or minus 21's not prime because we have 1 and 21 or 3 and 7, but 1 and 21 aren't perfect squares. 3 and 7 aren't perfect squares. So it works out it's just the square root of 21. You could type it into the 30XS, the yellow calculators, square root of 21, and it'll tell you that it's the square root of 21. It'll just give it right back. What do we need to do next? We need to minus 4 to get x by itself, which tells me that x is equal to negative 4 plus or minus the square root of 21. And that's the answer. Because the square root of 21 is not a nice number we can add negative 4 to or subtract negative 4 from. We have to approximate it as a decimal. That's it. That's the answer. Questions on any of this here? Are you ready for the next one? Okay. We feel pretty comfortable with these so far. So let's go on and keep working through this. So first step is a equal to 1. We're good there, so we can move on to step 2, right? Okay. So is a equal to 1? No. If not, make it so. We need to make it be 1. We have to divide everything by 3. Now, if you remember solving linear equations, how we always said do division last, always wait to do division last, this is the reason. Because we can't just divide both sides by that number and just affect the variable. We have to divide every single term by that. So with linear equations, you only had really one variable and a number. Move it over, divide, you're good. Here we've got more than one. So we have to divide each and every one by it. Here it's not bad. Because 3x squared divided by 3 is? Which is what we wanted, yes? Because we have 1x squared. Plus 12 divided by 3 is going to be 4, and we have x. Which this one works out nicely. Now this is not going to have any real solutions. Most likely it's going to be either irrational, well, irrational is technically real, or complex. But we can't factor to get them. So, okay, step 1, do we have it finished? Yes. Step 2, get the constant terms by themselves. So we can subtract 5 from both sides, which will tell us that we have x squared plus 4x plus blank is equal to negative 5 plus blank. C is equal to what? B over 2 squared, yes? What's the value of B? Positive 4. 4 divided by 2 is? And 2 squared is? 4. So how would our x squared plus 4x plus 4 factor be what? X plus 2 squared. Because the number inside the parentheses before we squared it was positive 2. So it's going to give us x plus 2 squared. Now on the other side, we have negative 5 plus 4 is? Negative 1. What do we do next? Square root both sides. Here the square root and square would cancel, telling us that we have x plus 2 is equal to plus or minus. What is the square root of negative 1? 1i or I, just I. Because by definition, I is what? The square root of negative 1. So we just have I. Over to the other side, so we would subtract 2 from both sides, telling us x is equal to negative 2 plus or minus I. Yeah. We can let him be. We'll.
You're just like, ew. At least it's not correct.
Yeah, it's probably going to be a wolf spider.
Yeah, wolf spider.
We can throw them outside later, because wolf spiders are nice. Yeah, they kill everything else. Any questions on this so far? Now, we'll look at this next one next, obviously. We'll look at a few more of these here. We're not going to look at a ton of them because I feel like y'all are getting the hang of this. Yes?
Yep.
So, looking at this one here, so first step, is A equal to 1? No. So, we need to divide. So, I would agree dividing by 3, but we need something else. Negative 3. Because again, the number in front of x squared needs to be positive 1. So negative 3x squared divided by negative 3 is going to be x squared. Then plus 6x. And then, so that was negative and negative. Negative again is going to be plus 2 is equal to 0. Now, this one here we can't factor. And one of the kind of giveaways that we won't be able to factor it is looking at really the factors of the first term, the number in front of x squared, and the third term. Well, the numbers in front of x squared is numbers for our factors of our last term, 2. Is there any way we can take the factors of 2 and add them together to get 6? No. So this doesn't work. We can't factor, and most likely graphing is not going to work either. So completing the square is the only method that we have that works. So we need to get this constant term to the other side. Subtract 2 from both sides. Now we'll get x squared plus 6x plus blank is equal to negative 2 plus blank. Now c is equal to b over 2 squared. What's the value of b? 6 divided by 2 is 3. And 3 squared is 99. So we will have x inside those parentheses, and then plus 3. X plus 3 squared equals 7. Then we would indeed, we'd solve by square rooting both sides, which would tell us that we have x plus 3 equals plus or minus the square root of 7. Because 7 is a prime number, so we can't take the square root of both sides. Well, we can't take the square root of 7 without getting a decimal. That's what I was meaning to say. And last but not least, we can subtract 3, telling us x is equal to negative 3 plus or minus the square root of 7. And that's it. Questions on this here? Let's do one last one, and then we will be done for today, I believe, and I think we only have one more on the note sheet. Okay. We ready to look at the last one? Okay. So if we're wanting to solve it by graphing or factoring, yes, we need this equal to 0. So we could pull up the graphing calculator and type this in to see if we can get a real answer. If we can get a nice number that's not irrational, doesn't have square roots as part of the answer, or imaginary, have I in the answer, and it's not a nice. So here, if we type this in, let me clear both of these out. We have 4x squared, what was it, plus? Because it was equals negative 68. So we would add it over to get it equal to 0. It doesn't cross at all. What that tells us is that the answers for this here are not going to be real. Not going to have real answers. But this here has no real answers, but negative 3 plus or minus I is the solution. Now, right, because we have that negative 68, yes? What's step 2? Get the constant terms on one side, yes? That's already done. So step 1, we need to get a equal to 1. So we can divide everything by 4. 4x squared divided by 4 is x squared. Plus 32 divided by 4 is 8x plus blank equals negative because 68, 4 does go into it. 17? Mm-hmm. Yeah, 17 and 17 is 34. 34 and 34 is 68. Now, C is equal to B over 2 squared. And what's the value of B? And 8 divided by 2 is? And 4 squared is? And again, we have imaginary solutions, yes? Which means the number by itself should be negative. Because the main way we get I is taking the square root of a negative number. And if we look at this here, negative 17 plus 16 is? Because if we're solving this and we graphed it and saw it didn't cross the x-axis at all, we should expect to take the square root of a negative. Or we expect I to show up in the answer. So we have x plus 4 squared equals negative 1. And when we square root, yes, this is going to equal, you're good, equals plus or minus I. than we would x is equal to -4 plus or minus I. Questions on any of this here? This here is not on your note sheet. I want to show it to you. Because up to this point, they're not been bad. Would y'all agree with that? So I'm going to work this through. Y'all can watch. Is a equal to 1? So we're going to make it so. So I'm going to divide everything by 2. 2x squared divided by 2 is x squared, yes? That's nice. Minus, so 5 divided by 2 does not simplify nicely, does it? So I'm going to leave it as a fraction. And 67 over 2 does not simplify nicely, but 0 does. And again, what we do next is we get the constant term. Decimals are going to be uglier. Because again, what are we going to have to do in the last step? We're going to have to take the square root.
Is a problem like this on homework?
I would have to look and see. But if one thing with these here, the steps that we do and have been doing don't change. The numbers and what they look like change a little bit, but these don't. Because none of this process has really changed, has it? Now finding C is b over 2 squared. Well, we have -5/2 divided by 2 squared. Now again, we don't want to do that whole thing at once because we need what goes inside the parentheses, yes? In the calculator, I can still do -5/2 divided by 2, which will tell us that it's -5/4 squared, which means inside the parentheses here, we're going to have x minus 5/4 squared. Bless you. Well, once I get this, I can square it. The negative is going to go away. 5 squared is 25. 4 squared is 20. So we have 25 over, what is 4 squared? I was like, that looked really weird, and there's a reason for it. I think so. We get this here. So getting the x minus 5/4 squared is not bad, because again, we're just pulling from what's inside the parentheses before we square it. Here, type it into the calculator. Type it into the calculator and let the calculator do it for us. Because we're going to end up with 16, because 2, 4, 34, 268. It's going to be negative 8. Go on and double check me on that. 511 over 16. That looks, for this here, yeah. 8 carry the 2, 6. Why am I doing 4? That's why. Because to get these to be the same, we need to multiply 67 by 8, which is going to give us an even bigger number. Now, next thing we need to do is square root both sides. Here, we're going to have x minus 5/4 equals plus or minus. Well, we're going to have I, because the fraction is negative, yes? So I comes out. Now, if I take the square root of 511, if I remember correctly, it's just going to be the square root of 511. It doesn't have any prime numbers or not prime, it doesn't have any perfect squares in it. Square root of 16 is 4. And last but not least, we can add the 5/4 to both sides. And when we do that, x is equal to 5/4 plus or minus the square root of 511 over 4i. They both have the same denominator, so I could add them, combine them to make it a single fraction. Either one of these is the correct answer. So the square root, or the completing the square method, works on all of them. It's not nice on all of them, but it does work on all of them. And that is it. (25, 26, 27, 28). Because 25 through 28, A is 1, so that's nice. 31, 32, 35, and 37, or 38. Yeah, you're good. Because 31, 7 goes into 7, 28, and 56. And 32, 6 goes into 6, 6, and 12. And 35, 4 does go into all three terms. But with 35, if you've noticed that there are x on both sides, we're going to need to get the x's onto the same side. Because again, our step 2, it doesn't change what it says. Get the constant terms by them, which means we need to get the x's over to the other side. And 38, this might be one of the last few times I put one of these on here, but again, it's one of the error detection. There is an error in that work, and again, it requires 2 parts. Explain what they did wrong and correct it. Explain what they did wrong and correct it. You don't have to have it in the most purest mathematical terms. Explain as best as you can what they did wrong. Okay? And as long as you don't have to hit dead center on the mark. As long as you hit the mark somewhere and actually explaining what they did wrong, that's what I'll take. Okay? You don't have to match the back of the book. Just explain what their error was.